So these are all linear word problems, which means you got a linear equation, a variable with exponent 1. So most of these that you're going to be doing will be simple integral uniform motion, percent mixture, value mixture, and work problems. Work done. So what do you notice about these three equations?
Yeah.
They all have equal sign, and they're all generally the same. Something times something equals something else, right?
Yeah.
C times A equals B, R times C equals D. And it turns out they're all done in a very similar manner, which is why they're all combined. But the word problems sound different, they're not really different in structure. So let's do as many of them as we can together to hopefully see this pattern. Okay, this is not in this textbook, so I'm going to skip. Well, at least this one's not in here. I'll probably do one of these word problems from your homework if we have time instead of that example. Let's start with example 3. An investment of $4,600 is made at an annual simple interest rate of 6.8%. How much additional money must be invested at annual simple interest rate of 9%? So that the total interest earned is 8% of the total investment. Now, when you read a word problem, most of it's like, okay, whatever, what happens? But you just want to identify two things. What type of problem is it? And what's it asking for? So of these problems, which one would you say it is? Simple interest, and what gives it away? There, it said simple interest, right? Several times. It also had percents, it had time, and it had an interest earned, money earned. Okay, the next thing is, what's the question asking for? It's usually the last sentence. How much additional money must be invested at? Okay, so we label that unknown first. How much additional money must be invested at annual interest rate of 9%? So we'll write that and label it. And this would be a 5-point problem on a test. And just for labeling your variable, you'll get 1 point. Easy point. Money invested at 9% return. So now, because we know this is an interest problem, it is P for principal. I'm just trying to remember which spelling of principal this is. Principal times rate, meaning interest rate, right? Times rate is equal to interest, which is the money earned. Okay, so I'm going to make a chart. You do not have to make a chart. I just find it organizes the information. So the first row of our chart is going to be given by the first investment. So what's our first investment? Yes, it's a 6.8% yielding investment. So how much money wasn't invested? Principal is money invested. $4,600 was invested, meaning it's the principal. And the interest rate, we convert the percentage to decimal. How do we convert 6.8% to decimal? Percent means divide by 100. So if we divide by 100, you would get the decimal moved to the left twice, 0.068. Okay, our next investment. So we first want to fill out the first two columns. What's our next investment? How much additional money must be invested at a simple interest rate of 9%? So it's a 9% investment. How much is invested? This is what the question is asking for. X is the money to be invested at 9%. And now we convert the 9% to an interest rate. So as a decimal, what is 9%? 0.09, move decimal to left twice. Very good. Once those first two columns are filled out, then we multiply across. We say 0.068 times 4,600 and 0.09 times X. Okay. Now we have to turn our brains and start thinking again. What does this box represent? 0.068 times 4,000. The total what? Interest means money earned from this investment, right? Okay, so what about 0.09x? Money earned from the 9% investment. So how do these relate to the whole equation?
Relationship.
What's that?
Proportional.
Okay, so we want to use the last line, right? So that the total interest earned is 8% of the total investment. So total money earned is these two added together, right? Total earned is 0.068 times 4,600 plus 0.09x. Okay, so that's the total money earned. Now I have this word is, which means what? Equals, very good. And 8% of the total investment. So how do I take, what does of mean? Times, so 8%, 0.08 times, what is my total investment? That means my total principal. So how much total money did I invest? I invested this much, 4,600 at 6.8%. I invested an unknown amount at 9%. How much should I invest total? 4,600 plus X. All right, so it's another unknown. So I'll write that here. 4,600 plus X is total principal. And I'm going to put that here. Okay, so setting up the problem is the hard part in the majority of the work. Are there any questions about setting this up?
Sorry,
Yeah.
0.08.
0.08.
Oh, the
is
8%, sorry.
Yeah, 8% of the total. Any other questions? So then solving the easy part, right? What would your first step be? Sure. Oh yeah, it's a calculator course, so we probably don't need to make it easier. Just go ahead and work with those numbers and plug them into your calculator. So, does anyone have your calculator? What's 0.068 times 4,600? All right, 312.8. Plus 0.09x, let me zoom in here, is equal to, what's 0.08 times 4,600? 368 plus 0.08x. Let's go ahead and subtract 0.08x from both sides. And let's go ahead and subtract 312.8 from both sides. I'm not doing this in my head. I worked it out before class so that we could get through more problems. 0.01x is equal to 55.2. And how do you get x by itself? Divide by 0.01, or more simply, multiply by 100, right? If you multiply by 100, then you get 1x is equal to, and move decimals to right twice, 5,520. And the question was asking for how much do we need to invest at 9%? The answer is $5,520 must be invested at 9%. Okay. Any questions about this? Yes.
Why, multiply by?
Because this is the tens place, this is the hundreds place. So this is literally the number 1/100. And moving the multiplying by 100 moves the decimal place to the right twice. So I'll get 1x, which is x. Okay, any other questions? Well, yeah, it's a calculator course, so just plug in 55.2 divided by 0.01, and it will spit out the right answer, right? Okay, next question. A plane leaves traveling 240 kilometers per hour. How long will it take a second plane traveling the same route at 600 kilometers per hour to catch up with the first plane if it leaves 3 hours later? Which type of problem is this? Uniform motion, what gives it away? Distance, rate, time, plane moving. Okay. Rate times time equals distance. What's the next thing we want to identify? Very good. What's it asking for? Rate times time is equal to distance. So what is it asking for? Let's read the last sentence.
How long will it take the second plane to catch up?
Okay, so that unknown, what do you want to label it? Maybe T for time? Time for second plane to catch first plane. Okay, so can we imagine this scenario? A plane leaves going 240 kilometers per hour. How long will it take the second plane traveling the same route? So they leave from the same place and they travel in the same direction until they meet. Okay, so we're going to diagram it. And with time, one leaves first, another leaves second, and catches up. All right, and in real time. So we know, well, that's my diagram. Let's set up the equation and we'll refer back to the diagram. Okay, so our rows are going to be the objects that are traveling. The first one we'll say is the first plane. Do we know any of the first two things about the first plane? The rate or the time? Very good. 240 kilometers per hour is the rate of the first plane. What else do we know? Do we know? Well, I see 600 kilometers per hour. What's that? Right, the second plane. It's going 600 kilometers per hour. Okay, what about the time traveled? Do I put T in the first time box for the first plane or T in the time box for the second plane? Second? Yeah, so we define T as what? Okay, so that's the time traveled by the second plane. Do you agree? time traveled by second plane. Okay, so then how long was the first plane traveling? So the first plane, the second plane leaves 3 hours later. So is the first plane traveling longer or less time than the second? All right, let's do the diagram again. First plane, second plane. Which one was going for longer? First plane, right? How much longer? 3 hours longer. So this is t plus 3. Are there any questions about that? Okay, now, could I have written t here and t minus 3 down here? Yes, this definition, as I define it, would be wrong with the words description, but that's okay. So when I solve for t, I'd be solving for the time traveled by the first plane as opposed to the second. So as I have it, I'm solving for t, the time traveled by the second plane. Okay, so the pattern now that's familiar is you fill out the first two columns. Two of the things will be given, like rates. The other two, likely unknowns. So that we put variables there. Let's multiply across to get the distance. 240 times t plus 3 and 600t. Okay, what does this top box represent here? Distance traveled by the first plane, and this represents what? Distance traveled by the second plane. From our amazing diagram, how do these distances relate to each other? They travel the same distance, right? Same path. Set them equal to each other. And that's the hard part. How do these relate together? They either add to make a total, you subtract them, or set them equal to each other. In this case, you're absolutely right. Same distance traveled. So 240 times t plus 3 is equal to 600t. And we solve. So I'm going to speed through the solving part because the setting up part is the hard part. So we distribute 240t plus 240 times 3 is 720 equal to 600t. We'll go ahead and subtract 240t from both sides. And we get 720 is equal to 360t. Divide by 360. T is equal to 2 hours. So it would take 2 hours for the second plane to catch up with the first plane. And I should just double check that. That's what the question is asking. T is in fact time traveled by second plane. All right, here's a tricky question. If I put t as the top box and t minus 3 as the bottom box, and I solved it, what would my answer be for t?
No, minus 2. 5.
It would have been 5, 3 hours longer, right? It would have been 3 hours longer, 5. And I would have had to plug back in and subtract 2 to get the actual answer. So it would be an extra step. All right, let's try. Well, any other questions about this? Does it look familiar? You guys have done these problems before?
Yeah.
Okay,
It's been so pleasant.
it's been a while.
Yeah.
All right, example 5. How many liters of a 40% sulfuric acid solution should be mixed with 4 liters of a 24% sulfuric acid solution to produce a 30% solution? What type of question is this? Percent mixture. Because it has percentages as opposed to value mixture. You'd be mixing like a value of an object, like I don't know, tickets costing different amounts for a child versus adult. Something like that. Okay, so we identified this as a type of mixture problem. In this case, would say percent times, it says amount, but really we're talking about amount of mixed solution. Equals, and it says quantity, but amount and quantity kind of mean the same thing. So I'll be a little bit more specific. Quantity of pure solution. So we're really talking about pure acid in that case. Okay, so what's the question asking for? I should label my variable. How many liters of 40% solution? X equals liters of 40% acid solution. Okay, so what am I mixing together? I have a 40% acid solution. What happened here? It just converted that to text. All right, 40%. Why?
You have it on the A setting, so that's when you write.
Oh yeah, I clicked the wrong pen. Thank you. Okay. The good news is it can actually read my writing. So 40% acid. What's my percent? Well, let's convert it to decimal. 0.4. And this is what the question was asking for. X is the amount of 40% solution. All right, next we have this combined with 4 liters of a 24% acid solution. So as a decimal, 0.24. And as an amount, 4 liters. So we fill out the first 2 columns, same as before. Many of them are given. And there's at least 1 variable, sometimes 2 variable expressions. Okay, any questions about this so far? So we multiply across 0.4x multiply across 0.24 times 4. And we need to first say, what do these red numbers mean? So 0.4x, what does that represent? It's the quantity of pure acid in this 40% solution. This bottom box, quantity of pure acid in the 24% solution. So we need to relate those in an equation. So what's it asking for? We want this to produce a 30% acid solution. Add them. Okay, so if we add them, then that gives me the total pure acid combined, right, in the mixture. Let me label this total pure acid in that combined mixture. And we want this to be a 30% acid solution. Very good. Set to 0.3 what? 0.3, so 30% times, and this should be the total of the amounts that we started with. What's the total of the amounts we started with? No, not 4. All right, I started with 4 liters of this and a known of this for plus X. All right, the total. Total means addition, by the way. Four plus X is total amounts. And this is what goes here. All right, any questions about this? Now, I want to go back to this investment problem. You notice the similarity here? We added this interest earned to get the total earned, or like the total mixture. And then we had an 8% interest on the total invested. Total invested, we added the principals. It's the exact same setup of the last one we just did. Okay, so this one's exactly the same. They look different, they sound different, but they're exactly the same. The total of the pure solution equal to 30% of the total amounts we started with. The total amount is 4 plus X. Yes. How do you know when to use it? When it's talking about a total, right? And it's saying to produce a 30% solution, it's implying a 30% of the combined mixture. But how do you know? Doing so many problems that it's painfully obvious. Doing lots of problems is very helpful. Okay, how are we doing on time? 17 minutes. Okay, I think we do have time to solve it. Let's continue solving this. So I'll go ahead and distribute the 0.3. 3 times 4 is 12. We need 1 decimal, so 1.2 plus 0.3x is equal to 0.4x, and we have 0.4 times 0.24 times 4 is 0.96. All right, so let's go ahead and subtract 0.3x. And let's subtract 0.96. And this is a calculator course, so I have no problem with you just plugging it in. 0.1x is equal to that would be what? Okay, so if we subtract that, that's let's borrow one. 0.24. And then the shortcut would be to do what? Close. Yes, very good. Times 10. And that gives us x is equal to 2.4. And we need to ask, is that what the question is asking for? And x was defined to be the liters of 40% solution. So 2.4 liters of 40% acid solution. Okay, any questions about this? No. Yeah, X is the amounts of 40% solution to produce a combined 30% solution. So how much, if it was asked, it could ask that, right? What if it was asking, what's the amount of the 30% solution? What would the answer be? Yep. We need to add together. 6.4, very good. 6.4 liters. Okay, now we have a work problem. Printer A can print a report in 3 hours. Oh, I gave it away. That's a work problem. Well, sorry about that. Printer B can print the same report in 4 hours. How long would it take both printers working together to print a report? So what gives it away that this is a work problem is that you have two things working together to complete one task. In this case, the task is to print a report. Okay, here's a hypothetical question. It takes 3 hours for one printer, 4 hours for another. Would it take less than 3 hours, between 3 and 4 hours, or more than 4 hours if they're working together?
Because 3 is the lowest they can go.
It's a little bit tricky, right? So maybe let's talk about it in terms of cleaning this room. If I could clean this room in 2 hours and you could clean it in 1 hour, we're working together. You could do it by yourself in 1 hour. And if I helped you, it would go faster, right? It'd be less than 1 hour even. Does that make sense? So we know our answer should be less than 3 hours, right? Okay, well, let's talk about how to set this up. The variable is how long would it take both printers working together? Time for both printers to print the report working together. Okay, so our equation is rate of work times time worked equals the part of the task completed. Okay, so we'll say we have printer A and printer B. Okay, so if printer A can do the entire thing in 3 hours, what's its rate? This is a little bit tricky. When you talk about rate, let's say a car, right? If a car goes 40 miles, let's say a car goes 40 miles in a half hour. What's its rate? $80 miles an hour. How'd you get that? 40 miles over 1/2 hour. Dividing by 1/2 is multiplied by 2. 80 miles per 1 hour. So it's really saying how much is completed in 1 hour. So you divide by the time, right? So in this case, we're doing one task in 3 hours. That makes sense? So we do 1/3 of the task in 1 hour. Does this idea make sense? Okay, so that's kind of tricky, but the time to complete it is 1 over that time. So part B, what would my rate be for printer B? 1/4. So one task, one report printed in 4 hours, well, 1/4 of it is printed in 1 hour. So that's our rate. Okay, how much time is printer A working? No, what, sorry, this is now talking about working together. When they're working together, how much time? And this is what we define as T, right? T is the time that printer A is printing when they're working together. What about time that printer B is printing? Yeah, because they start at the same time and they finish at the same time, right? So we multiply across and we get T over 3 and we get T over 4. Okay, and once you fill this out, these are going to be easy because these represent the part of the task completed by each one, and together they should complete how much of the task? All of it, 100%, which as a decimal is what? 100% as a decimal is 1, because it's 1 complete task. Okay. So from here, we just solve for T. Well, is there any questions about setting this up? Yes. I just multiplied T over 1, so 1 times T and 3 times 1. And T over 1. Yeah, so I multiplied the numerators and multiplied the denominators. I didn't have to, but I did. Okay, so in your homework from last night, how did you solve these problems? If I see an equation, I see fractions, I think, let's get rid of the fractions. Yeah, the least common denominator, 3 and 4 both divide into what? 12. So let's multiply both sides by 12 to eliminate the fractions. So what's 12 times T over 3? 4T. What's 12 times T over 4? What's 12 times 1? Okay. And so 7T is equal to 12 and T is equal to 12 over 7. What's our calculator say? Well, let's say it's equal to 1 5/7 hours. Is it hours or minutes? Hours. Does that make sense? Less than 3 hours? Yeah, that's feasible. Okay, any questions about that? Yes. Uh-huh.
Can you explain how you get 14?
How I got 14?
Yeah, from the 12. and-
Oh yeah, 12 over 1. So I multiply. Well, I reduce common factors. 12 is the same as 3 times 4, and I can reduce the 3's. Get 14. Are we comfortable with that? 12 is the same thing as 3 times 4, so I can reduce the 4's. Get 3T. Okay. Proportion. Things are proportional. An equation that sets 2 rates or 2 ratios equal to each other. Walking 4 miles in 2 hours will lose 650 calories. Do you believe it? You wish? It depends on the person, right? But we'll just say on average, walking at the same rate, how many miles would a person need to walk to lose 1 pound? This is very valuable information. Do we have any guesses before we start?
Around 12 miles.
Around 12 miles? Any other guesses? Yeah. Just walking. Okay, so how many calories in a pound? Wow, 3,500. Yeah. Anyways, huh. So what are the things we're comparing? So what's the question asking for? How many miles? So let's say X equals miles walked at the same rate, so at 2 miles per hour, to lose, or we'll say burn, 3,500 calories. Wow. Okay, so we're comparing miles to what? Yes, how many miles to calories, right? So my options are, if I'm comparing X over 3,500 or 3,500 over X. That makes sense? Let me include units. Miles, calories. I want to compare the same thing in the previous equation, which would be what miles with what calories? 4 miles, 650 calories, okay. 4 miles, 650 calories. So miles both need to be on the top, calories need to both be on the bottom, or I could flip them both. I'd prefer X to be in the numerator because I want to solve for X. Okay, how would you solve this? Cross multiply is a way to solve it. It is a slower way to solve it. What's a faster way to solve it? Sure, calculator, but do what with the calculator? How do I get X by itself? Well, so just multiply by 3,500. So cross multiplying sure works, but it's going to be faster to just multiply by 3,500. X is equal to 4 over 650 times 3,500. Did anyone plug in the calculator? 21.54. Is that shocking? What does that mean? You have to walk 21.5 miles to lose a pound. Wow. That's not worth it. Or you can what? Or you can bike or run. Yeah, let's do that. That's also assuming you're not like, burning calories just from living, which happens. Okay, we have a similar triangle problem on the homework. It turns out if all these angles are exactly the same, it's what's called a similar triangle, which means all the sides are proportional. So we could set up an equation where if I want to solve for X, I can divide two sides. So I could say X divided by 7 is equal to, do you agree with that? 8 divided by 12.8. It needs to be 12.8 divided by 8. These ones need to correspond to each other. And these ones need to correspond to each other. So it's proportional. So just be careful you don't flip one of them by accident. And that's the only tricky part. So how do you solve for X? Good. Multiply by 7 is the faster way. And we get 11.2. Okay, that's all we have time for. I'm going to solve this problem now because it's a semi-tricky homework problem, but you're free to go at this point. What's that? It's just a perimeter rectangle problem. Yeah, probably. It's just hard to search for, the specific example.
Excuse me.
Yeah.
Just to be clear, it's 1.1, 1.3, 1.4, and 1.5, right?
Yes.
All those are doing what?
Yes.
Thank you, thank you.
Yeah.
That's good news for my.
I'm not on Blackboard yet. How would I do it? Like having yeah, like Western, old Sun's way.
You're gonna have to share with me your email.
Okay.
Write your email here. I'll send you the link, to this OneNote. Yeah, here's a pen, here. So I'm gonna send you the link to the
Write
OneNote.
it again, I already have.
What? Your email.
Oh.
And this notebook has your homework assignments, so you can start looking at them. But you're gonna have to just catch up whenever you have
Yeah.
Blackboard.
Just to make sure, you don't actually have to write, you don't have to write the notes, right? Or like, just, I don't know what's going on about it, it's like writing notes, the stuff